Hi, my name is Matt O'Malley, and I'm an architect with OPAL Architecture, and I'm also a co-founder of GoLab. We're a startup manufacturing wood fiber insulation right here in Maine. When we became aware of the triple decker challenge, we were really excited because it's asking such an important question. Residential energy accounts for 20% of all CO2 related emissions in the US. And in order to address the climate crisis, we need a solution that addresses the residential energy consumption. The second thing is there are a lot of houses out there. There are 139 million houses and apartments, 38% of which were built before 1970. Upgrading the walls and attic insulation of these residential buildings alone would reduce CO2 emissions by 575 million metric tons annually, cutting housing's share of total US emissions in half. So when we're thinking about a solution for the triple decker, what we really wanted to focus on was something that was scalable, flexible, and cost effective, something that could be implemented not only in Boston for the triple decker here, but residential structures across the United States. And so flexibility, accommodating the unique conditions of existing buildings was critical and foremost. The second thing is that we had to have a solution that could be applied to the exterior because we can't ask 139 million families to leave their homes for a month or two while we go about renovating and upgrading the existing housing stock in the US. That's just not realistic. So we needed an exterior solution. Three, we needed a solution that had good building science behind it. Specifically, if we're going to encapsulate these buildings in insulation, that insulation needs to be vapor permeable to allow moisture to breathe out of the buildings and not get trapped, causing mold, mildew, and worst of all, possibly bad indoor air quality for the occupants. So we can't save energy, but make a huge indoor air quality issue for people going forward. That's just not a good trade-off. And finally, fourth, the key is that we need to use an insulation and other building materials that come to the job site with a carbon negative footprint. Because if we use conventional insulation, foam and fiberglass to do this renovation, while we'll be saving energy the day that we install that insulation, the problem is to pay for the carbon footprint of those materials, it will take 10 years of operational energy savings. And quite frankly, we do not have 10 years to wait to have the benefit realized of adding insulation. So we're proposing using wood fiber insulation. It's been made in Europe for 25 years. It's renewable, recyclable, non-toxic. It's vapor permeable, so there will be no building moisture issues. And finally, it's carbon sequestering. So it comes to the job site with a carbon negative footprint. So the energy that it saves, you realize on day one. And that's critical to address the climate crisis quickly, timely, and efficiently. Thank you very much.